In this video, I will be going over the fundamental theorem of calculus, both part 1 and part 2. So I'm going to first start off with part 1. And this part of the theorem states that if f is continuous on a closed interval ab, and then we have this function g, which is defined as g of x equals the integral from a to x of f of t dt. And here a is just some number. And x is between a and b. So x is inside this closed interval. And g of x is also continuous on the closed interval ab and differentiable on the open interval ab. So g prime of x equals f of x. So this theorem shows you how to solve for the derivative of g. And if you notice, we just plug in the x for the t, and we ignore the a. For my first example, we want to find g prime of x when g of x equals the integral from 1 to x of 1 divided by t cubed plus 1 dt. We can see that our a value here is 1, and that our f of t is 1 divided by t cubed plus 1. Now we can apply the fundamental theorem of calculus part 1. So we get that g prime of x equals f of x. So we just plug in x for t, and you get 1 divided by x cubed plus 1. For my next example, we want to find g prime of x when g of x equals the integral from x to 1 of cosine of the square root of t dt. So here we can see that our intervals are switched and that our a value is not on the lower limit. So we're going to want to switch that. And we can see that our f of t is cosine of the square root of t. So in order to flip the integrand, we multiply by 1. We multiply by negative 1. So our g of x equals the integral from 1 to x of cosine of the square root of t dt with a negative in the front. And so our g prime of x will equal f of x. But since we have a negative in the front, it'll equal negative f of x. And as we can see, our f function is this integral here with the negative out front. And for our f of x, we'll plug in x where we see t. So our final answer is g prime of x equals negative cosine of the square root of x. For my next example, I have h of x equals the integral from 2 to 1 over x of sine to the 4 of t dt. And we want to find h prime of x. Since our value here is 1 divided by x rather than just x, we're going to want to use substitution. So we'll let u equal 1 over x. And so our u prime is negative 1 over x squared using the power rule. So here we're applying a form of the chain rule. When we have a value in the interval that is not x, but rather a function of x, we're going to take the derivative of that and multiply it in the front. So here our u prime is going to be what we multiply in the front of our function. And that is negative 1 over x squared. And then our f of u is sine to the 4 of 1 over x, because our u is 1 over x. In simplifying, we get the derivative of h is equal to negative sine to the 4th of 1 over x divided by x squared.